All right, let's dive in. Today, we're going to unpack a huge topic, one that's truly a cornerstone of modern health: immunizations. We all know it's important, but what's the actual science happening inside our bodies? Well, let's break it all down.
So, first things first, what even is immunization? Well, the simplest way to put it is that it's the process where you become protected from a disease because of a vaccine. Think of it like a training program, a boot camp, really, for your immune system. It gets your body's defenses geared up and ready to fight off a real infection down the road. And this training can happen in a couple of really different ways.
And here are those two methods, side by side: active versus passive immunity. With active immunity, your body is the one doing all the work. It learns to produce its own antibodies after getting a vaccine. But with passive immunity, you're basically given a temporary loan of pre-made antibodies. And really, the biggest difference, the one you absolutely need to remember, is how long they last. Active immunity is the long game. We're talking protection that lasts for years. Passive immunity, it's more like a short-term shield, fading away after just a few weeks.
Okay, so for our deep dive today, we're going to focus on that long-lasting protection, active immunity. This is the whole shebang when it comes to vaccines. It's all about creating a durable, lasting defense by actually building your body's own immune memory, teaching it to spot and wipe out threats for years, even decades to come.
So how do we achieve this active immunity? Well, it's mostly through two main kinds of vaccines: live attenuated and inactivated. Now, a live vaccine uses a super weakened or attenuated version of the actual germ. You can think of it as a very realistic but totally controlled training simulation for your immune system. An inactivated vaccine, on the other hand, uses killed germs, or sometimes just little pieces of them. This is kind of like giving your immune system a most wanted poster so it knows exactly what the bad guy looks like, without ever having to face it in a live fight.
Let's look at some real-world examples to make this stick, starting with bacterial vaccines. Over on the inactivated side, you've got some really common ones like the tetanus and diphtheria shots. And for live vaccines, probably the best known example around the world is the BCG vaccine for tuberculosis.
And it's a pretty similar picture when we turn to viral vaccines. The inactivated list is long. It's got everything from hepatitis B and HPV to the annual flu shot most of us get. Then, on the live side, you have those childhood classics like the MMR for measles, mumps, and rubella, and the varicella vaccine for chickenpox. It's kind of amazing when you see it laid out like this, how these two different technologies protect us from so many diseases. Now, here's a really key difference to remember. Because live vaccines are so much like a real infection, they kick off a really powerful and thorough immune response. And what that means is you can often get full, long-lasting protection with just one single dose.
But what about inactivated vaccines? Well, since they aren't using a live bug, that first immune response isn't quite as, well, loud. That's why they almost always need a primary series of a few doses, and sometimes even boosters later on, to really build up and maintain that strong immune memory. So, how do these actually get into our bodies? Well, the vast majority of shots you'll get are given as an IM, or intramuscular injection. That's just a shot that goes deep into the muscle, like in your arm or thigh. But, and this is important, there are exceptions. That BCG vaccine for tuberculosis we mentioned, that one's given intradermally, which is a much shallower injection right under the surface of the skin. Okay, so we've covered what vaccines are and the different types. But knowing what they are is only half the battle. Just as important are the rules for giving them safely and making sure they actually work. So let's shift gears and get into the practical side of things. When it comes to giving more than one live vaccine, there's a really important rule about timing. You can either give them all on the same day, just at different spots on the body, or you have to wait at least 4 weeks between them. Why? Well, it's to make sure the immune response from the first vaccine doesn't mess with the response to the second one. But what if you're mixing and matching? Say, one live vaccine and one inactivated one. Good news. In that case, you don't need to wait at all. They don't interfere with each other, so you can give them pretty much whenever. Of course, safety is always, always number one. And there are a couple of very clear reasons to hit pause on a vaccine. The main ones are if someone is pretty sick with an acute illness, or, and this is a big one, if they have a confirmed history of a severe allergic reaction to a previous dose of that exact vaccine. Now, this next part is just as important because it helps clear up some really common myths. Let's talk about what are not reasons to skip a vaccine. Things like being born prematurely, having a family member who had a bad reaction, or a baby being breastfed. None of these are reasons to withhold a necessary vaccination. All right, for our final section, let's talk about situations that aren't so black and white. Special groups where the decision to vaccinate involves a really careful balancing act. It's all about weighing the risk of the vaccine against the risk of the actual disease. So, for pregnant women, the general rule of thumb is to avoid live vaccines. That's because there's a theoretical, very small risk to the developing baby. But this isn't an absolute never. If a pregnant woman is at a very high risk of catching a really dangerous disease, say yellow fever during an outbreak, doctors might decide that the benefit of getting the vaccine is actually greater than the potential risk. It's a case-by-case call. Now, here is a group where live vaccines can be truly dangerous. We're talking about people who are immunocompromised, like cancer patients, organ transplant recipients, or people on high-dose steroids. Their immune systems are already weakened. That live attenuated vaccine that's perfectly safe for a healthy person could potentially overwhelm their system and actually cause the very disease it's supposed to prevent. So what's the game plan for them? Well, that's where inactivated vaccines are a lifesaver. They are completely safe for this group because there's no live organism that could cause an infection. Now, there is a trade-off. Because their immune systems are weaker, they might not build as strong of a defense, so the vaccine might be a little less effective. But you know what? Some protection is almost always way better than no protection at all. And, getting these vaccines to people safely isn't just a doctor's job. It takes a whole team. I mean, just look at the growing role of clinical pharmacists. They do so much more than just give the shots. They're on the front lines, educating patients, spotting who needs what vaccine, and working with the entire healthcare team to make sure communities stay protected. So from the basic science to the tricky rules for specific people, it's pretty clear that immunization is an incredibly sophisticated and life-saving field. And as the science just keeps getting better and better, it kind of leaves us with a big question, right? How can we best support all the healthcare professionals, the doctors, nurses, and pharmacists who work so hard to use these amazing tools as safely and effectively as possible? Definitely something to think about. Thanks for tuning in.